There's some that I have like questions about. Like when I looked it up online, they kept going with the problem. Or there's like, we'll get to it when we get there. Okay.
Sounds good.
For number
So,
one, oh wait, what were you saying?
so I got up to 6 and 7.
Okay.
So what I ended up doing is I printed out the Chegg papers because
Mhm.
they're identical,
Yeah.
just
Yeah.
so we could follow along.
Yeah. I've done 8 and 9. The only thing is 8. I don't know why the moon is in charge of like why the tides are predominantly due to the moon. I don't know that. But I
Oh,
didn't
that,
really think about it. And then for 9, so I solved it and I think I got it right, but one of the numbers that they were using and that I used seemed wrong.
which one?
I'm trying to remember. I think it's the R. It's like 4.22 or
Oh, for IO?
something. And then they put like I have it as to the 5th power and I think they had something else. I don't remember what they had. But I wanted to put 5th because that's what the paper says, but theirs is something else, but then it would change the result of the problem. What number
Okay.
do you use? Or what number does it say?
So on here, so number 9, we know it says find the mass of Jupiter based on the dead orbit of one of its moons and compare results with its actual mass.
Yeah.
On the Chegg thing, find the mass of Jupiter based on the fact that Io, its innermost moon, has an average orbital radius of 421,700 kilometers
Mm-hmm.
and a period of 1.77 days.
Yeah.
So, from what I am inferring, they rounded the 4.22
I think they did too. Okay. Well, then I
because,
think we'll be fine.
yeah, because on this, it gives 421,700 kilometers for Io, which would have been 4.21, but
Yeah. I got 1.891. So I guess I could run that to 1.90 times 10 to
yeah.
the 27th, which is
That,
almost identical to what they have. Kind
okay, then you should be fine.
Yeah. Okay. So let's go back to number 1.
Sounds good.
So for 1, I did 24 multiplied by 60 minutes over an hour multiplied by 60 seconds per minute. And that gave me 86,400 seconds.
Yep.
And then for B, it's the W is equal to the 2 pi over the time. So I have 2 pi divided by the 86,400. And I got 7.29 times 10 to the negative 5th radians per second.
So I do have a question because I got 7.27 and you got 7.29 and Che got 7.29. So I don't know how I got a 0.27.
I don't
So
have my calculator with me, but let me type it into my computer.
yay for internet.
Exactly. Okay, so it's 7.278. So I think you are right. So it should be, when you round it, it should be 7.27. Not
Okay.
because it's 0.00007268. But if you round it, then it's 727.
Okay.
Yeah, you're right.
It's hard when it's that small.
Yeah, does it really matter that much?
No.
And then for C, I have V equals RW. So I
Mm-hmm.
multiplied the 6.4 times 10 to the 6th. And then the one we got in the last one, which is going to be different now. So what did
What
you
I got, sorry, what I got is 465.28.
Okay. Okay. All right.
They
For
got
2, this is the part where I was confused. So for the angular velocity, I figured out, so D is 200, and so half of that gives you R, so your R is 100. But then you're gonna divide it again, so you use 50 meters, and then you do W equals the square root of gravity divided by the 100 meters that we use, the 100 meter radius. I can't talk right now.
Oh, so I messed that one up. Okay.
Oh, what did
I
you?
used the 200, not the
No,
100.
yeah, I did, because I figured, because the radius is half of the diameter, right? So I divided by 2, and then
No, you're right on that. I misread the.
313 radians per second.
Wait, what did you get?
0.313. What'd you get?
I got that too, even using the 200.
How? Let me double check my math again since I was wrong last time.
Okay. So what formula are you using?
I was using, so I have the A, well, I have A equals V squared divided by R. And so I rearranged it so V equals R, and then the other equation is V equals RW. So then I supplemented RW in place of V. So I have A equals RW squared divided by R. And then when you isolate W from that, I got W equals the square root of A over R.
Okay, that's what I have, except it's mine's written more like W equals the square root of 2G over D. So gravity over distance.
And how do we know which one is right?
Well, they both came out with the same. I'll do my equation, do yours.
I just
And
pulled it up and my number is the same. I got
the same.
0.313 again.
9.2 times 9.8 divided by 200.
But then if you make it like RPMs, then it's a totally different number. I mean, it's not that different because you're just saying how many there are per minute instead of per second.
Right. Well, luckily we're not looking for
Yeah.
that. No, I get the same thing. So
It is.
I'm going to infer that we're doing it right. Just two different
It's just 2
equations getting.
Okay.
Yeah. So.
I mean, I guess as long as we're the same number, that's all that matters.
Yeah.
Okay. For 3, I said centripetal force is uniform circular motion where the direction always points to the center of the orbit. And then I said any force or combination of forces can be centripetal. I spelled that wrong. I spelled all of it wrong. Let me change it.
They're big words. I see it and I start thinking of like a centipede. It's like, no, that's not right.
Yeah, exactly. That's kind of where I went wrong too. So what did you say for your definition?
So I said it is a force that acts towards the center about which it rotates. And any type of force can be a centripetal force. Example, a tether ball attached to a rope, the moon and the earth. And this one I found, which I'm still trying to figure out, but the friction between the floor and roller skates is a centripetal force.
I mean, I guess since the wheels on the roller skates are moving in a circle, like, like it's, but I don't know. I mean, I guess, but
Yeah.
I don't like it.
But therefore, a singular combination of forces can be a centripetal force.
That's what I said too. Okay, for 4, I didn't get B because I, but for A, It says that the only force is coming from the mass since they're all being affected by gravity. And so the direction will be downwards.
That's what I put too.
Okay, and then B, I don't have anything. What did you put?
So the centripetal force increases, which will push the passenger toward the center of the vertical loop, is what I put. So as it increases, it will pull it towards the center more as it reaches the top. So instead of like C is opposite. So if it's
Yeah, I
increasing
don't
speed
see.
towards
I
the
said
top,
it pushed the passengers away from the center, so it's like pushing them back because the centripetal force went down. So that's just the opposite.
it's just the opposite.
Okay. Then for 5, so I use the equation tan theta equals V squared over RG. And then I rearranged it to get V. So that ends up being the square root of tan theta multiplied by R and G. And so using that, I got 18.9 meters per second.
That is correct.
Okay.
I put 0.8 just because I didn't know how.
Okay.
But that works. 18.9 thing. Yeah.
Okay, 6. For some reason, mine didn't print off any parts. Like it's just the introduction and the picture, but it doesn't tell you to do anything. But like
I've been trying to
print it off weird. Like my 7, instead of saying 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 9.8.
So I emailed the professor about that.
Oh, and did he give you what they actually are?
So 7, ignore the force. It's just the 9.8.
I kind of figured that's what I did. So I did that for 7 because I was like, that doesn't make any sense.
All right. Yeah, I wasn't sure, so I actually printed off. I made sure that page was printed off of Chegg.
Yeah.
And it's the exact same thing. Now 6, I've been trying to look because he says it's in the book.
Yeah. Is it?
Which, and if it's the one I'm thinking of, then it is the exact same as. So this right here. If we can find it, it should look very similar to this one.
Oh, okay.
So
then let me go. Does it have the questions in it?
the book is supposed to have the questions in it.
Yeah. So what is it? Did you just pull up the book or no?
No, that was from Chegg.
Okay.
And so far, all the Chegg questions I've had, the 1 through 9, just to verify, they're all the same.
Okay, so then it's probably the same as the one you have.
Yeah.
So then what is it asking?
Here we go. Let's go to 244. 244. So what this one says, and I'm hoping to find it as well. Oh, here it is.
You found it? What page is it on?
245 of the PDF book. It is problem number 28. So let's see. There's supposed to be a part A and a part B. So part A, show that theta as defined in the figure, when as shown, is related to the speed v and radius of curvature r of the turn in the same way as for an ideally banked roadway.
Okay. What's B?
And that's the exact same on Chegg. Chegg is, the PDF says calculate theta for a 12 meters per second turn of radius 30 meters as in a race. They're the exact same, the Chegg and.
Okay.
So that'll help us a little bit. But I did notify him of that, so he should notify the
be like,
who
you
do
guys
it.
don't have to do it. Never mind.
I wished. He emailed me and was like, "Oh, just go find it in the book."
Like, but I don't want to.
I know.
I feel bad because last week it was like such a long week for me that like I was working on the individual exercises and I got to like a stopping point where I was like, I can't do this anymore. So I turned it in. And then for the quiz, I got it like I got an 80 on it the first time I did it, and then I went and took it again and I got an 80 on it and again and again, and I was just like, we're taking an 80 this week. And it dropped my grade by like 3 points.
It's crazy.
I'm not allowed to do that again, unfortunately.
What?
I
That's
know. I went from like
weird.
a 94 to a 91 point something. I'm like,
It dropped you that much?
yes. I mean, like I got like a 77 on the homework because I gave up. But like luckily, like I showed my work. So on the other one where you submit it, I got more than that. Like because I like got more than halfway and then I like made a mistake. So I got almost full credit on the one I turned in. But on
That's
Maple
good.
TA, I got a little less.
I am not liking the Maple TA.
I hate it. I hate it with every fiber of my being. Like I feel like I just read into it too much and then nothing makes sense for me. But it's the worst.
There's only been, I think, twice where I've seen it work, but that's because the teacher actually went in to make sure it was working every semester.
Yeah.
Like right now, I'm doing CAD and we have to use Maple TA.
Ooh. Yeah, this is
And
the first time I've ever used it, but I'm not loving it. Full
it,
disclosure.
it's all good. It doesn't work.
No, it doesn't. It's garbage. Sorry,
Uh,
I'm trying to like rewrite this equation so I can get started on A.
you found it?
Yeah, I'm looking at it now. So for A, you would have theta equals tan, the inverse tan, and then it would be 12 squared over.
So what? Let's see.
Wait.
Wait, does it want a free body diagram?
Oh wait, I'm accidentally calculating B. Let me
Work
fix
on that.
B.
That's fine. We need B. B should be easier.
Yeah, it is easier.
And it looks like um, for A,
Yeah.
which is weird, it's almost like a free body diagram is needed, according to Chegg, to help explain it.
Ew. I hate those.
Luckily, no, I know this is kind of bad, but they do give one.
Okay, I have
I'm
for
really
B.
willing to fudge it because that's ridiculous.
Yeah. Let me try to put this into my computer because I didn't do it. I forgot to print it off.
It's okay. If
Cotangent is the inverse of tangent, right?
what? Tent?
Cotangent, is that the inverse of tangent? So I don't have to figure out how to do that in Google.
Um, from what I know, there's a difference.
Oh, is there? Okay, then I'll just do
Yeah.
inverse.
It's weird. I've come out with different solutions whenever I do that.
Okay, let me try this again.
So, what are they doing with this?
Okay, let me go run and grab my calculator. I'll be
Go
right back.
for it. Okay. The fraction of forces. So it wants us to find, show that theta as defined as shown is related to mean radius of curvature of r of the turn in the same way as for an ideally banked roadway. That is. So So theta equals tangent inverse V2 slash RG would be equal to tangent theta of V squared over RG. And
Okay, we'll try one more time.
all right, I'm trying to decipher this from Chegg on how to explain A.
Okay.
That it's becoming beautiful. Let's just say that.
No, that doesn't sound good.
It's physics. What's new?
Okay, for B, I got 26.1 degrees. Does that sound right?
Exact answer.
Crushed. Okay, if only we knew how to do A now. So,
It from what it's showing, like the free body diagram isn't required. They just showed it for reference, because from to show that theta works, correlation with the velocity and curvature. It's like the force is heading in a diagonal way. So that's where the free body diagram just shows it. But then rearranges the formula so it can prove that it's in correlation.
I'm just looking at the book right now.
Does the book actually show how to do it?
No, I'm just seeing if it has an example that's similar. So is it wanting? So I think it's wanting us to take the two equations.
Just one equation.
Well, I thought it wants for vertical and horizontal.
Not for A.
But I thought he's going because he's moving. Maybe not.
So all it's wanting for A
Okay, what is it?
is, so you see the equation, inverse tangent of V squared
Over
over
R.
RG.
Yeah.
So it's wanting to know how theta
Yeah.
works in relation to the V squared and the R.
Well, if you have a larger velocity, you'll have a bigger. You know what I mean? Like if you have a bigger R value, you're going to have a smaller theta, and if you have a larger V value, you'll have a larger theta. Does that make sense?
That does.
Like, is that all we need to say?
I think it works. The way that Chegg is showing it is pretty much doing a substitution of force and with the normal force and the force going sideways. But what you just said is a simple way of saying that without being too complicated.
Should we draw a free body diagram just in case?
If you want, we can copy this one that's right here because it's the exact free body diagram as what they show with the book. Just that there's gravity.
Yeah.
That's the only difference.
I don't understand what this is even asking us. Because I'm looking it up and I find different things where they all give weird answers.
Show that theta is related to speed and radius of the turn in the same way for an ideally banked roadway.
I mean, I feel like the equation shows that theta is related to the velocity, so
which it does.
yeah. So
I think go with the definition you just said though. Like put the equation and say what you said because r with r and the speed, it determines how much of a degree you need to get that.
yeah.
So I, I don't see a point in trying to making it too complicated. Okay. It would have been nice though if they had put the questions with the worksheet though.
Yeah.
Don't worry, we're almost halfway through the semester.
Are we really though? I think we're only on week 5.
There's 14 weeks.
We're not halfway. We'll
We're
be,
about halfway.
we'll
Week
be
7's
halfway in
halfway.
2 weeks. It seems like way too long.
I know. It's like the days go quick, but the weeks stretch out.
Exactly. Wednesdays are always my busiest. Wednesdays and Fridays are always my busiest because that's when I do the lab and the individual exercises. And I feel like those days take forever.
Especially the individual exercise.
I know those things, they make me so mad because sometimes I'm like, I swear I'm doing it right. Like I'll find similar examples in the book or online and I'll work it the same way and it won't take it. But then it's like, once it won't take it that way, I don't know how to fix it. Like I don't know another way to try it. And so then it's just like, well, I guess we're leaving it like this.
I know. There was one question I've used probably about 5 to 7 different equations at
I know
least.
that's my problem. And then you try so many things that like you probably did the right thing, but you just messed it up a little. But you have no way of knowing that. So
There's so the very first time I used Maple TA, there was a hint button.
really?
There was.
Oh,
And
I was
now
using that on the very first exercises, and it was so helpful. But now
it
there's
was
nothing.
great. Yeah. But like so we have like how did I do type thing, right?
Yeah,
Just to check it.
that's
Yeah, there
kind of
used to
nice. But
be a
then you can't
hint
make it
button.
right until you do it.
Yeah. But there used to be a hint button, so I don't know what they did with that. It used to be really helpful. So
Okay, sorry, I was just writing that up.
no, it's all good.
I think I have it now. And then B, I got 26.1.
Booyah.
For 7, I said that Anna is right, and I said that the object is in free fall, but since it's stuck in an orbit, it's constantly falling, and it's the centripetal motion, it's constantly falling towards the Earth, but it won't go out of the orbit. What did you say?
It's both.
It's both?
Combine the two arguments. So a
Okay,
satellite is in constant free fall, but
yeah.
due to gravity and the centripetal force, it stays in orbit. So I don't agree with any of them if you have to pick one or the other, but together their argument is perfect.
Okay,
Because yes, it is free falling,
yeah.
but gotta love a spinny Earth. I'm not using that big word; it's too big.
I know. Okay, what did you say again? But due to gravity and centripetal force, it what?
It remains in constant free fall. Yeah, you already made mention of gravity. So
Okay. And then for 8A, I use the equation A equals Gn divided by R squared. And then that gave me 3.326 times 10 to the negative 5, but I rounded it to 3.33.
okay.
Is that what you got?
Yeah. Well, I made it all the way up to 5.
Oh, okay. That's fine.
And
I can tell you how.
that's where I have Che.
Okay. And then for B, I used the same thing, but then I did it for the sun. So
Okay.
instead of using, in the first equation, I had 6.673 times 10 to the 11th multiplied by 7.35 times 10 to the 22nd. And then I divided both those by 3.84 times 10 to the 8th squared. And then for A, I have 6.673 times 10 to the 11th, negative 11th, multiplied by 1.99 times 10 to the 30th, divided by 1.496 times 10 to the 11th, which gave me 5.934. So I rounded it to 5.93 times 10 to the negative 3 meters per second squared. And then for the ratio.
Is that just for the sun?
Yeah.
Okay.
And then for the
Okay,
ratio,
I see.
I divided the moon by the sun, and I got 0.00562.
Sweet. Okay, I followed.
What else to do with that? And then I also don't know why the tides are predominantly due to the moon.
I can explain the tides to the moon.
Okay, explain the tides to the moon, and I'll write it down so we can turn in my sheet.
Okay. So first, I'm just going to explain it, and then you can write it down, all right? So first you have the Earth and the Sun. It's going around. So you just have one force. So it's not going to change the tides. Once you put the moon in there, you have a different gravitational pull acting on the Earth. So a second gravitational pull. And since water is a fluid much more than Earth, it affects water more.
Okay, what do you want me to write?
Okay, so let's see. The moon is a second gravitational force.
Okay.
On the Earth, which affects the properties it's like clear in my head, but it's like hard to word it. So it affects the properties of the tides due to them being more fluid than the Earth's crust.
Okay. And then for 9, I think I've got it. I'll tell you what I did. So first I solved for T. And so
Okay.
I multiplied the 0.00485. And I multiplied that by 3.16 times 10 to the 7th seconds per year. And I got 1.5 times 10 to the 5th seconds. And then to get M, I use the equation 4 pi squared divided by G multiplied by R cubed divided by T squared. And then using that, I got 1.8909 times 10 to the 27th, which I rounded to 1.891 times 10 to the 27th. And their answer was 1.902.
Okay.
Does that look like what yours is saying?
Well, mine says hence the magnitude of the mass of Jupiter is 1.89596 to the 10 times by 10 to the 27th kilograms. So it's actually really, really close to what you have.
Okay.
And I believe
Tell me
yours
what
is.
you did one more time.
Well, the thing is, the different number they're using, like what we're given is 4.22.
Yeah.
They're using
Oh, so
4217. What?
they're using a slightly different number.
Slightly. So the one you have is just fine.
Okay. All right. Okay. Did we have any more questions on them, or are we done?
That's 9. That's all 9 questions.
Oh. Okay. Um. So do you want to turn in any of yours, or I could just turn in all mine because I feel like this time there's not any that I'm like missing, and that way it's easier and you don't have to send me anything. Or we can take a picture if you want and use one of yours
Um,
because I don't care either way.
let's make it easier on you.
Okay, that's fine.
So you can turn in yours. If he asks for mine, I can turn in what I have.
Oh, does it say that we need to have both parts? It might. I don't. Let me double. I think it might actually say that we need to include both people's. Let me make sure before.
Why do they become so oddly specific?
I don't know. Some of the things though I don't do, and I don't feel like they count off. Like that whole method where it's supposed to be like, and outline your answers on each page, and da 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 da. Did you read that? Or it's like how to do your homework. And then before you turn it in, all of them say to do it a certain way, but I forget half the time. And it hasn't counted me off, so. Do we have another exam this week?
We do have an exam at the end of this week.
Bummer. Okay.
So I might as well give you a page because it says, however, the instructor may adjust individual grades based on participation.
Oh, yeah, then let's do that. Okay, so you can send me like, you want to send me like 1 through 4 and I can turn in 6, 7, 8, 9?
Okay, I'll send you the, yeah.
Okay.
1 through 4, right?
Yeah.
Okay. Yeah, I'll send you those 2 pages. That's ridiculous.
Put number 5 in it as well. So it's just the first 2 pages, and then I'll turn in the last 2 pages. Does that sound good?
That sounds good.
Okay,
Dang
wait.
it, this class is killer.
I know. I'm ready to be done. Okay, I'll get back in. I'll see you next week.
Sounds good. You have a great rest of your night.
You too. Bye-bye.